I'm Rebecca Fiebrink. I'm a senior lecturer at Goldsmiths in London. I am a computer scientist by training, but also a musician, and I do a lot of collaboration with people who are game designers, artists, composers, instrument builders, doing a bunch of other cool creative work. And in my talk today, I'm going to talk a bit about some of the work that I do, but I'm hopefully going to point out a few of the projects that are out there and some of the companies that are out there that I find inspiring and interesting. So I'm going to go over to sharing my screen, and I'm going to show you some slides and hopefully some video. So a lot of talks I give are to people who may not have as much machine learning expertise as all of you, but I'm going to guess that there is probably a wide variety of machine learning expertise in the mix today in the audience. So I'm going to very, very briefly go over the basics of what you need to know about machine learning to understand the rest of my talk. And I'm going to spend most of my time talking about how it can be used to create not just new music and music tech, ignore that, replace that with new music, art, games, and other stuff. And of course, one of the big questions that I'm interested in is what does machine learning and the things we can do with it right now, the things we will be able to do with it soon, what does this mean for the future of technology, but also the future of human creative work? So 3 things that probably most of us know that machine learning can do, right? We can think of it as being capable of finding patterns in data, right? I have a bunch of customers, maybe of my business. This is a common machine learning scenario. I'm running a business. I want to make more money. I want to understand who my customers are. So I give data about my customers to a machine learning algorithm, and it tells me, hey, you have these maybe clusters of demographics. Or maybe I want to use my data to make predictions, right? I see that certain customers are buying one kind of product and other customers are buying another kind of product. And maybe even to learn this, I have to give this data to a machine learning algorithm who can pull out that pattern. And of course, ideally, when I see a new customer, I want to be able to predict what product they're going to buy and make a good recommendation, right? And of course, one of the applications of machine learning that's getting all sorts of attention right now in the creative space is using machine learning to generate new content. To say, okay, well, here's a bunch of images, for instance, let me make a new image that's similar in some sense, right? And you can go on GitHub now and you can download your own cat generator so that in case we run out of pictures of real cats on the internet, you can generate more. Probably many, but not all of you have seen the Google Inception ISM project. This is, I would say, the moment when machine learning for creative work really entered, the mainstream hype a couple years ago. So if you, for instance, take a neural network, you train on images of something, let's imagine images of lots and lots of different animals, you could then use this network in a generative way, and you could generate new animals. You could also change the way you're applying it just slightly and say, well, I don't want to generate a new animal completely from scratch, but I want to start with an existing image, for instance. And I could say, all right, neural network, take whatever animal-like things you see in this image and just make more of them. So slightly alter this image. And of course, we get something like this, where we have a machine learning system that's able to hallucinate animals or other objects or other patterns in data like photographs of the real world. Right? And this is pretty cool. This is definitely a new aesthetic. This is quite different from previous machine-generated art. And as you can see, it's actually coming up with some pretty crazy, thought-provoking, interesting things. So if you don't know about this project, do go look it up. It's called Inception ISM. There's a really great blog post from Google talking about how they do this. And of course, you could apply this to all sorts of other kinds of data in creative domains as well as non-creative. One of my favorites as a musician is this GitHub project, which uses the same kind of generative techniques, but to generate new album art for new albums. And so you can see, something pretty essential about what albums look like has been learned here, even if the text doesn't make any sense. If you've been paying attention in the music and audio space, you've probably heard of Wavenet. For those of you who haven't, I'm going to tell you a little bit about this because this is a cool project. Wavenet is a music and sound generation system which uses generative models trained on just big data sets of raw audio, right? So this isn't MIDI data, these aren't musical scores. These models themselves, before they're trained, know nothing about what music is or what a piano is and so on. However, they're able to, with some clever training and some big data sets, produce some stuff that actually sounds quite interesting. So I'm going to give you an example here of what Wavenet produces when you train it on a bunch of piano examples. And I'm going to do a little experiment here. I'm just going to play this out of my computer speakers and see if you guys can hear it. So. Check in, you can hear it, excellent. Here's another example from the same model. Okay, so that's, I think, pretty good examples of what Wavenet does. You might, take an honest think for yourselves of, whether you're going to run out and buy an album generated by this, but I think we can all agree that it sounds like a piano, and there's something classical music-like about it. So machine learning is happening, and of course, there's just questions about what we then do with this. A company that's working, I think, pretty effectively in this space so far is called Doopdeck. They're actually based in London, and they're not trying to solve a problem that's as hard as Wavenet. They're not trying to look at raw music files and generate new music. They're dealing with other simpler musical representations, and they've got also people who know about music and can implement some musical constraints. But they are a company whose business is selling automatically generated tracks of music to new people. And especially for people who are making their own YouTube videos, for instance. If you can say, hey, I've got a video, it's a minute and a half, I want a soundtrack to that video. I'm not a composer, I don't want to write it, I don't have the money to pay a professional composer to write it, and I don't even want to pay the money to license something else. So for a lower fee, you can go to Doopdeck and you can have them generate you a track of your chosen genre. Here I've selected synth pop. You can choose a mood, which I've chosen aggressive, and you can set a duration and even when in that track you want to hear the climax. And you can keep generating these until you come up with something that you like. And then if you want to use that in your own content, you can pay them a small licensing fee. So here's an example of the aggressive synth pop track that Doopdeck made me. That goes on for a while. I'm not going to play the whole thing for you, but you get the idea. And I'd encourage you, go to the Doopdeck website. It's free to play around with it and see what kind of stuff you get out, and you'll get a good idea of what they are currently capable of doing. The last example of generative stuff that I want to make sure to mention is work by Janel Shane. If you don't know her, you should definitely follow her on Twitter. She's also got a blog on lewisandcork.tumblr.com. And she's doing, I think, some of the most interesting and just fun experimentation with using generative models, specifically neural nets, to generate text. And one of her projects, for instance, took recipe names and just fed them into a generative system that is capable of coming out with new recipes. And one of the nice things about the way that she's set up this system is she's done a couple experiments. She's able to tune the system a little bit to say, try to be really conservative. For instance, generate me new recipe names that are a pretty safe bet that are really conventional. And when you do that with her system, you get cream cheese soup, cream of sour cream cheese soup, chocolate cake, chocolate cake, chocolate cake, chocolate chicken cake, which are pretty awesome. And then you can say, okay, well, maybe I want the system to be a little bit more adventurous, generate me some stuff that might be outside of the norm. And it comes up with things like beef soup with swamp beef and cheese, whole chicken cookies, and then some of my favorites, out of meat as a recipe, and crock-pot cold water. Right, so this is the state of the art where we are right now. This is what you can do with a pretty good general generative system infrastructure and a pretty good data set, and not a lot of expert level knowledge and tuning. And I would argue that this Wavenet example is in some ways the classical piano music of like beef soup with swamp beef and cheese, right? So I'm going to play this again for you. All right, so it's intriguing that a computer would come up with that, but I'm not going to go like order beef soup with swamp beef at a restaurant, and I'm probably not going to sit down and listen deeply for pleasure to the Wavenet stuff. Now, this stuff is going to get better, but it's coming up with some interesting results already. So I would say the work that I've talked about so far has a model of creativity that's sort of, it's like a big red button, right? Where you have a button, it's like press to create. You press that button and you get some stuff from a system that's been trained on other stuff. It'll give you something similar. And I think a lot of the ways that the media presents this work when it presents it is that, all right, that's it. We are, all going to be replaced by algorithms, and, maybe we're a couple years away from them making compelling content, but that's pretty much the future of creativity. Obviously, I'm not ending my talk here. There are some things I want to say about this. So first of all, I've put some asterisks here. My first asterisk is that the systems that I've shown you so far are really, they're built by people with PhDs for the most part. They're also, for the most part, built by people with a lot of data. And these systems are cool, but not everybody can just go out and say, hey, I want to make my own generator to do X, Y, Z. The second caveat here is that the amount of interaction that people can have with these systems, the amount of guidance that people can give to these systems varies, but often it's not a lot, right? Often you're kind of stuck with maybe whatever big data set you have, and you have to be quite creative about how you tweak the algorithm to give you something different or to hone in on a creative idea. If I generate a Doopdeck track and I say, well, I really like the bass line there, but I've got this idea for like a melodic riff that I think would be great, I'm pretty much stuck. And the fact is that a lot of human creative processes involve taking your ideas, your expertise, your knowledge of the domain, and using that in your work over a longer iterative process. So these types of systems, yeah, they're going to get better. Some of them probably are going to make a lot of money in different contexts, but I don't think that they are the end to the question of how do we support human creativity with machine learning. So let's talk about some questions that I am really interested in beyond this. So I'm interested in how machine learning can support people's existing creative practices, people who are composers, musicians, game designers, visual artists, interactive artists, dancers, and so on, right? We have a lot of people doing fantastic work. A lot of these people are already using technology, but often technology, the sorts of things they can do with the technology is quite limited, and it involves one set of expertise, which may be a narrow subset of what they can do in their practice. I'm also interested in how machine learning can expand people's creative capabilities, allowing people who might be novices or students to make more interesting or more sophisticated works of art, allowing people who are professionals to do things that they couldn't previously do. And practically, the work that I'm going to show you in the rest of this talk is not looking forward and saying what's going to be possible in 20 years, but what can we do right now with these people to support their creative practice. And one key to realizing a lot of the opportunities in this space is, I think, to recognize that potential sources of data that we can feed into machine learning systems are all over the place. So a lot of the work that I do uses different kinds of sensors. So I've worked with Microsoft Kinect, for instance, to get information about how a person, maybe a dancer or a game player, is moving in space. We can get data about, your heart rate or your activity from fitness bands. We can get EEG signals or EMG signals that tell us something about what you're paying attention to or what your body is doing. We also have all these other sources of data that we create either intentionally, like when I write things on Twitter, that's data that can be captured and fed into a system. And anytime I interact with software, if I'm making a new piece of music within a piece of music software, I'm making a new graphics, making new graphics in Adobe Photoshop, all of that can be captured, right? The content that I'm making is already captured in a digital system. The process by which I make and then edit that content can get captured. And these are all sources of data that could allow us, again, to do interesting stuff with machine learning, to find patterns in it that then we show back to you to help you reflect on what it is you're doing. We could make predictions. We could allow you to control things, or we could remap from one kind of data to another, and we could generate new data, right? Generating new music or art in your style, or applying edits that you make, in your style, but maybe even, well, we'll get to that. So again, if we think about the conventional supervised learning paradigm where we want to make predictions, right? We have our customers, we have examples of customers and what they buy. We can actually use this to make predictions for things that maybe don't have such a strong or conventional business case. So one of the applications of my work is actually building new musical instruments, where I might have a performer who's moving around, and we're looking at how they move using some sensors. It could be computer vision, it could be sensors that they wear on the body, it could be an object that they're pressing or moving in some way. And we can formulate the problem of saying, hey, I see the person doing this, what sound should we make? We can formulate that as a prediction problem. And in fact, I can create a data set that says, all right, when I do this thing, maybe with my hand in front of my camera, I want to make this sound. And when I do this other thing with my hand, I want to make this other sound. And from that, I can make a training data set, train a machine learning algorithm that sees new hand positions and makes new sounds. And then you have a musical instrument, which could actually be capable of making totally new music that you can't play with either an acoustic instrument or like a MIDI keyboard. Or you could make a new musical instrument that's playable by somebody with a disability who can't pick up a violin, for instance, and play a violin. So with that, I'm going to check back on, all right, everybody seems happy and chatting away in the background. I'm going to do a live demo, and hopefully this is going to work. I'm going to go back to, let's see. I'm going to go back to the screen, and I'm going to run a couple things. So first of all, I'm going to run a little piece of code that takes data about what my hand is doing in front of a leap motion. So I don't know if you can see this in the webcam or not. I'm holding my hand over a sensor, and then you should see on the screen the data about my hand position that sensor is picking up. So I'm going to use that. I'm going to turn that into a new musical instrument using supervised learning. And of course, one of the interesting bits here is that I can't go online and download like the canonical hand position control for musical instrument data set. That doesn't exist, but I can create that data set And one of the things I want to communicate to all of you is that actually creating that data set can be really easy, and I can build something super cool from a very, very small data set, which is not something that is often talked about in more conventional machine learning applications. So to do this, I'm going to run a piece of software that I started making I made the first version in 2008, 2009, and I've been using this for teaching as well as in a lot of my own research for the last 8 years or so. And the software is called Weka Nater, and it allows you to build supervised learning systems in real time, kind of from whatever data it is that you want. You can make a data set on the fly, like I'm going to do in this demo. So I'm going to tell Weka Nater to actually take this data from the leap, and that's going to be our input features. So I'm actually going to capture the X, Y, and Z position of each fingertip here in space. And then I'm going to build a musical instrument for me to control with my hand. So I'm going to now open up a pretty standard music programming environment called MaxMSP. And this environment allows me to play music, but also manipulate it a little bit. And in fact, it's very powerful. I could do all sorts of musical things. But in this demo, I'm going to keep things pretty simple. And I'm going to tell Weka Nater I want to use machine learning really to build a model that looks at these 15 fingertip input positions and controls the speed, pitch, and volume of this max patch. So I'm going to control 3 things here, and I'm going to build a data set from scratch to tell my computer how I want the relationship between what my hand is doing and what it sounds like. The data is going to communicate what I want there. All right, so let's see. There's going to be a little bit of lag here with the screencasting, but it should work. So I'm going to start out maybe just with my hand position right here, and I'm going to turn the sound on. Ooh, yeah, we've got lots of lag. No, I don't want to test USB performance. Go away. All right, I'm going to try this one more time. Yeah, I think we're going to be all right. I'm restarting my leap. And I'll give you a flavor of this, and then I'll also show you where to go for a YouTube video if you want to see some more demos. All right, so should be picking up my hand here pretty soon. Sorry, guys. All right, we're going to go to my backup plan, and I'm going to show you a video where this is all working and my screen sharing doesn't kill things. So here we go. This is from a talk I gave at Google last year. I'm going to show using the leap and using the same max patch. So let's run this.
8-year-olds can do this. I've done this with 8-year-olds.
Yeah. All right, let's make this full screen for you. Yes, you can see it. Okay. So here we go.
Musical instrument design, also relevant to gaming and accessible interfaces. This is a leap motion. And so I'm actually here, I'm just extracting the X, Y, and Z positions of each fingertip in space. So I've got 15 dimensions of input, not so noisy here, but still high dimensional. And what I want to do is connect this to a sound synthesis algorithm with 9 control parameters. And the sound synthesis algorithm, hopefully, it's not going to sound like that. Let's open this up again. My sound synthesis algorithm gives me lots of different sounds to choose from. Right? And if I want to build a controller where I use this leap motion to control this, I've got to program a mapping function where I've got 15 inputs controlling 9 outputs, and everything's continuous. So that's pretty complicated. It's going to take me a long time if I just sit down and try to program it. So what I'm going to do instead is use Let's see, I've got 15 inputs and 9 outputs. I'm going to use a straight up multi-layer perceptron neural net for each one of these outputs, and I'm going to start by finding sound I like. And I'm saying, all right, I want that sound to happen when my hand is here. So here's one sound, and maybe I want the pitch to go up, and my hand goes up. And so here's another sound, and let's see if it learned that. All right, now I've got a stupid theremin kind of thing, and I can start making new sounds, and maybe I want, that's my favorite one, I want that to happen when I start doing this claw kind of thing, right? And now I can... Let's turn that up a little bit. All right, so that's a lightning fast demo.
All right, so there you go. There is a, I'm going to stop sharing my screen for a moment. I'll show you, this is the motion sensor. This is called a leap motion. And just to recap, because I know the video quality wasn't perfect, what I was doing was giving it an example and saying, hey, when my hand is here, I want to make that sound. And when my hand is here or in that shape, I want to make this other sound. Recording training examples, capturing that on the spot, training a set of neural networks, and then running them in real time where they were getting data about what my hand was doing and using that to control the sound synthesis. And then I can iterate on that, right? If I don't like what it's doing or I want to make it more complicated, I can give it some new hand positions paired with some other sounds, and I can add that to my training data set and retrain on the spot. So we're working with very small numbers of training examples here, building something really quickly. And what I get is something I can just play around with and iterate on. So in a nutshell, that's how you can use Weka Nater to build something from scratch. This is using an interactive machine learning approach where you're actually editing the training data kind of on the fly, which doesn't make sense for a lot of more conventional machine learning problems. But here, where the thing I'm wanting to predict is, not a concept out there in the world that I'm trying to model, but actually, something that communicates maybe a musical idea, or I want to build something that's comfortable for me to play. It's a much sort of less well-defined objective that I'm trying to satisfy. And I understand, as a human being, whether the musical effect that I'm aiming for is being met or not in the system that I've built. And if not, again, it makes sense here for me to be able to change the training examples. So that's Weka Nater in a nutshell. You can go download that. It's free, it's open source, all the good stuff. In the rest of my talk, what I want to do is talk a bit about the research that I've done with that, and especially about why machine learning is interesting and why it's useful for the people who've used Weka Nater, but also talk more broadly about systems that are out there that I find really inspiring, that are giving human composers, musicians, artists, creators, new ways of doing things. So there we go. In summary, right, what are these techniques actually good for in the real world of creative practice, and what can we learn about supporting human creativity with technology? So let's share my screen again. Okay, I've got 8 pretty, hopefully easy to grasp points to make here. The first one, as you saw from this demo, machine learning can be a really easy way to start working with sensors, right? If you want to build something that reacts to what a person is doing, whether that person is a dancer or an athlete or somebody, say, watching a video, there's all sorts of data that we can get about those human activities, and we can map that into controlling something. It could be controlling music, it could be controlling an interactive video game, it could be controlling interactive art, it could be just remapping that data into some domain that is then shown or played back to that person to allow them to reflect on what they're doing in a different way. And of course, there are some sensors that are so high dimensional or so noisy that it's impossible really to use them effectively without machine learning. Certainly a lot of biosignals would fall into that category. All right, so there's all sorts of cool sensors which now, instead of becoming something that requires you to really have a lot of signal processing expertise and a lot of time programming to work with them, they can be something that you can build with in just a few minutes, like I did in the demo. I'm going to mention a couple works of art and music that you might want to look up. Anne Heggie, for instance, is one of the first composers I worked with when I was building the first version of Weka Nater. And she's built some really stunning, beautiful music with new musical instruments. Using Weka Nater, this piece called From the Waters is on Vimeo. And what she's got here are actually PlayStation golf game controllers that she's using machine learning on these controllers to allow the performers to go through what looks a lot like a sort of yoga sun salutation. And she's mapping the movements of the performers to sound. So I'll play you a quick clip of this. So I like this piece. I mean, musically, it's very beautiful. It's very beautiful to watch, but it's a type of playing music and playing with music that you can't do with an acoustic instrument. Another piece and instrument that falls into this category is something by Michelle Nagai called Martlet. Again, this is on Vimeo. And she's actually made an instrument out of a piece of tree bark. She put light sensors in the tree bark, and she plays this instrument by moving her hands across the bark and casting shadows on the light sensors. Again, really interesting to watch. Certainly, I think more compelling to watch than watching people stand on stage in front of a laptop typing. But also, of course, it's interesting in that it suggests a different gestural vocabulary for playing, right? So the ways that you can play this, you're never going to make music that sounds like Mozart on this. If you want to play Mozart, pianos are great for that. String orchestras are great for that. This, because of the physical form of the instrument, actually suggests a very different type of music. I'm not going to play you a clip from this, but it's on Vimeo. In the art space, some people have made some really interesting things with Weka Nater and sensors as well. This piece is basically uses a webcam that you wear on your head, and that webcam is attached to a classifier that classifies whether there's anything that looks like a screen in the view of your webcam. And if there's a screen, then it is attached to these special glasses that become opaque. And so the only time you can actually see the world is if there are no screens in your field of vision. So I got a chance to try this last year. It was pretty cool. An artist, sort of creative coder guy I really like is named Andreas Refsgaard. And he's made a bunch of really cool online experiments that he's made videos about his experiments with machine learning. In this project, he made a facial expression to meme generator using Weka Nater. So he's actually, no matter what facial expression you make, it matches you with the appropriate internet meme. So that's another kind of fun project. And one of my favorite really quick whimsical projects is this one. This is from a student in a workshop that I taught last year. This is the same leap motion sensor that I showed you in my demo. And the student attached it to a little cardboard robot that she made. And this is all it does, right? When you wave at it, it waves back at you, and it's called HiBot. And of course, HiBot is something that, I'm not sure that it's worth making a HiBot if it takes you a month, maybe it's not worth making it if it takes you, several weeks. But if you have 20 minutes, you can make HiBot. And I like that about making things easier to create with sensors. It opens up this space to these sort of whimsical, not totally useful, but fun interactions with the digital world and the physical world. All right, the second thing I want to talk about is that machine learning, because it learns from data, can support really highly personalized experiences. And that's an underexploited opportunity among systems that are out there right now, like Magenta or Doopdeck, for instance. Because if we're able to learn from the data of an individual person, like you saw in the demo, and make something just for that person, I find that really exciting. These pictures are from a set of workshops I did a few years ago with people with disabilities, where some of them had very severe physical disabilities and couldn't play acoustic instruments. In general, most of the people at these workshops had never, certainly hadn't had the musical training to, be necessary to walk up to a guitar and jam, or another instrument and jam. But we built a bunch of instruments that pretty much anybody could play, and we were able to customize instruments so that, for instance, no matter how you can move, we can build you an instrument that's playable in a way that's comfortable for you. So this is a set of ongoing work, actually. I think this idea of personalization is also really interesting in the professional space. If you've ever done any audio editing, you know that audio production can be really laborious. It takes a lot of training to get something that you're happy with, right? To know how in the world to set an EQ curve, for example. And once you've learned how to do that, there's only so much work that saves you, right? When you sit down to start working on a new project, you still have to do all of this time-consuming work to get to a point where the outcome is reasonable. So some researchers at Northwestern and also in London have done a set of projects around learning how people make these curves, right? Learning how expert creators do editing processes. And if we're able to learn how you do an editing process and learn how that might generalize across different types of content that you're editing, well, we could then, when you start working on a new piece of content, we could save you some time by applying that editing process in a way that's maybe personal to you, rather than something that's learned from absolutely everyone in the world making top 40 music, because maybe you don't want your music to sound like everyone else. Likewise, of course, we could learn personalized EQ curves or other types of production processes from Jay-Z or from other well-known musicians, and you could have that in your music software. When you open it up, you could say, hey, I want to edit my stuff so that it sounds like this person, which I think is pretty fun and probably coming. I had a PhD student at Princeton who just finished this summer who was working with personalization in a slightly different way. So obviously, everybody's Twitter feed is different. And the ways that people want to interact with social media are often quite different. And your desires for interacting with social media might actually be different from day to day, or they might evolve over time. And what Katie was doing was experimenting with alternative interfaces to Twitter and other social media and sort of high data interfaces, where if you could imagine, there's some compelling alternatives to just having this interface that dings at you or beeps at you or gives you an alert on your screen every time something happens. So the question she started with was asking, hey, what if I could take somebody's Twitter feed and turn it into an ocean soundscape? Right, something that's relaxing. Something that I could maybe put on in the background while I do other work. But maybe something that's also interpretable to me, right? Maybe I know that the seagull is that one friend who tweets really annoying stuff every now and then. And I don't really want to know what they're tweeting, but maybe, if that seagull starts going crazy, I might go and start paying attention. And obviously, in order to build this kind of mapping from your social media data to sound, we probably don't want to do that in exactly the same way for each person. Not the least because you care about different things, you have different densities of tweets in your feed and so on. So Katie's work took a very similar approach to Weka Nater underneath, where you could say, here's an example of my social media feed. Here's an example of a soundscape. Now build me something that will allow me to listen to Twitter in a more ambient, relaxing way, while still maybe informing me of some of the things that I care about. The next point I want to make is that machine learning is exciting to me because it can empower more people to become creators, right? As you saw in my demo with the Leap Motion, I didn't have to program anything in order to make a new musical instrument. And that makes this kind of paradigm a really easy thing to use with kids. It's an easy thing to use with non-programmers, and it allows people to explore what, for instance, what they might do with sensors. It allows me to start teaching interesting interaction design concepts to my students at university without relying on them also being able to code a lot. Another example which is worth looking at is something called Microsoft Songsmith, which you may have heard about. This is a bit older of a project now, but it allows you to sing a melody, and the software will come up with a backing track for that melody. And so this has been used by a lot of schools to allow students to make new songs that sound a lot better than what they are currently able to do with sort of limited musical skills, but they can sing a melody and hear what the song might sound like. This is also really fun to sing a song that is well known, right? You can go sing an Aerosmith song and ask it to generate you an accompaniment with a polka band, which there's a lot of that on the internet, and I recommend that. There's also some really interesting developments in the professional software domain right now. Adobe, for instance, is starting to integrate some intelligence into their products in new ways. In the audio space, iZotope is a company that is starting to actually take some of these data-driven approaches to audio editing and audio production and put it in their software. So you don't have to go and, for instance, learn about mixing and mastering and be really bad at it for several weeks or months or years until you're able to do something useful. You could just say, hey, I recorded this song in my basement. I'm not a professional musician, but can you please master it so that it sounds not horrible? And they've got tools that are starting to let people do that. In the visual art space, there are also a lot of interesting tools, a lot of them online, that are starting to allow people to experiment with different types of visual art or different types of interactions. And a lot of these, again, are on GitHub, and you can download the source and play around with them. One of my favorites is this thing called Neural Doodle. So I can make, basically a Microsoft Paint sketch with very limited artistic skills, and then I can apply the style of a famous painting or a non-famous painting onto that artwork. And of course, yeah, the obvious application of this is to allow me to make fake paintings by famous people. But I actually, if you play around with this, it's creatively really satisfying, and you find yourself entering into that same kind of iterative creative loop where you say, okay, now that I know that it does this with this input, what happens if I start changing this a little bit? And so you're able to explore within a pretty sophisticated looking space of visual art, even though you don't have skills beyond being able to do some stuff with your mouse and being able to look and bring a sense of curiosity and attention to the process. A similar project, which I really like, is called Edges to Cats. Again, there's a bunch of variations on this on the internet, but this allows you to make a sketch of a cat, and it'll generate a new cat for you. And of course, results will vary in their fidelity to real cats, but part of that is, actually really fun. And if you approach this as a tool for allowing people who aren't great artists, who aren't great with Photoshop, you're giving them a tool to make a really, interesting new kind of art. I think it's, pretty effective in that, even if it's not something you're going to sell to a museum. Next, I'm going to talk about something that is pretty much absent from the discussions around machine learning in certainly the machine learning research space, which doesn't really play into a lot of the media hype around machine learning for creativity, but which in my experience in my research turns out to be incredibly important, right? If you are making something for someone in the real world to use, you're often making something for a person with a body, right? So you might be making something for a dancer, for a musician, for an athlete, for a visual artist. All of these people, right? People doing creative work, especially if there's a component that's not strictly about sitting at the computer coding, there are embodied practices, right? Embodied expertise that they've developed probably over their lifetime. And right now, computers don't really usually take advantage of that. Tom Igoe has a really nice caricature that I often show my students, which is, this is what you look like to a computer for most computer interfaces that you use, right? You're an eyeball, maybe you're using your ears a little bit, and you have a finger that you can mouse with, or maybe a few fingers you can type with. The rest of your body is completely irrelevant. And even if you're a programmer, right, you're writing a new creative coding tool, right, or you're coding up something to make new visual art or music, that's pretty much it. You're using your brain as well, and you're using a lot of mathematical knowledge. But in the real world, if you look at a lot of other human creative work, people are using their body in very sophisticated ways, right? Think about playing the violin and the fine motor control that's required, but also all the feedback that people are getting from the instrument itself, right? Think about the ways that people's visual systems and fingers and ears are involved when they're doing something like making audio, or what their fingers and eyes are doing when they're making a painting. Often this knowledge is tacit, right? If you asked a violinist why he's, how to achieve a particular sound effect, he's not necessarily going to be able to explain it to you very well in words, but he can definitely demonstrate it to you. Same thing for a painter, right? If you say, hey, how do you paint XYZ? The painter isn't going to be able to give you an algorithm for how to do that, but she can probably demonstrate it for you. And because of that, using machine learning systems ends up being a much better match than programming, where you're writing algorithms explicitly in order to make creative work on a computer, right? If you can have somebody demonstrate, hey, here's an example of a thing that I want the computer to be able to do, that's a lot easier for the person. And again, there are lots of sources of data that we can draw on, whether it's the actual creative artifact that someone has made, or whether it's the process that they've gone through for creating that artifact. Another, I think, very substantial benefit of using machine learning to create new works of art or music or other types of creative artifacts is that it can just be faster. So if you compare making an instrument with Weka Nater, like I showed you in the demo, to making an interactive sensor-based system by coding, there's a huge difference in the amount of time that it takes, right? Weka Nater, it might take me 30 seconds. Writing that same kind of thing using code is going to be, maybe an hour, maybe a day, depending on what it is I want to do. And when I've talked to artists and musicians using machine learning in their work, this is often a theme that comes up again and again, because actually a lot of these people are really good programmers. They are really good with a lot of different technologies, but just allowing them to make things more quickly has a huge effect on their work, right? When I've worked with musicians and artists using Weka Nater, it's not that making something more quickly allows them to finish the job more quickly and then go do something else. It's actually that they're able to explore more ideas in the same amount of time. And there's lots of really interesting research in design, especially, that examines the importance of allowing people to prototype, to reflect on those prototypes, to explore lots of ideas. All of these things are known to lead to better final outcomes, whether you're making a new work of art or a new computer program, or you're building a bridge and you're using simulations and so on. So again, we can think about machine learning tools that allow you to make, whether it's a new musical instrument or a new picture of a cat, really, really fast. That's going to have deep impacts on not just the amount of time it takes someone to do something, but how happy they are with it in the end, or how satisfied they are with, how well the thing they've made satisfies their conceptual goals, for instance. All right. Let's come back to talking about generative algorithms, because I am very excited about them. Again, I'm excited about them not because I want a big red button that just makes me stuff and I can replace the people, but because generative algorithms can also, I think, fit really interestingly into people's processes, right? So again, the classic application of this is to say, I've got a data set, generate me something similar, right? Generate me new pictures of cats. This may or may not be super useful. However, another thing that these algorithms can do is, from these large data sets, right, learn about where in the space, for example, where in the space of possible pixel values are realistic faces, right, or are realistic cats. So, those of you who are technical machine learning people, I'm talking about, learning a manifold within a high dimensional space, where on this manifold you have content that's actually similar to the content in your data set. And if you've got that manifold, then you can start to do things like morphing, right? You could say, all right, I want to start with this idea, but I want to do maybe a random walk around this idea. I want to take my artistic artifact and I want to vary it in ways that aren't completely random and bad, because if I start manipulating pixels in this image in a random way, it's not going to look like a face anymore. But if I stay on that manifold, I'm going to get other stuff that still looks like faces, and that might actually be interesting. Or I could say, hey, take me on a walk from this face to this face, and that suddenly becomes a really powerful artistic tool. In the sound space, Google Nsynth is a good example of this. You should go play around with this online. It's basically doing this for synthesis algorithms. So I'll play you a little demo here and show you how it works. This is, these are synthesized sounds learned purely from the raw audio of a synthesis, like a sample library. Going and playing around with this. I like this because this is suddenly a way not of saying, hey, machine, generate me some new sounds, but it's an interesting control interface where I could imagine, hey, I want to explore a set of hybrid sounds and I want to get to some sounds that are limited in a way by maybe some sounds I know are interesting, but nevertheless are sounds that nobody's ever heard before. And of course, you can do this with images. Those of you who haven't seen the smile vector examples on Twitter, you can take a picture of anybody who's not smiling, and you can walk through this space, right? Walk along this manifold in the direction that corresponds to smiling. And yeah, some great Twitter examples of this. And of course, another set of work that I'm really excited about are work by people who are using machine learning itself as an artistic medium. Not to say, hey, I want to just generate new stuff to replace people, but I want to comment on what it means maybe to be human, or what it means to be a machine, or what it means for machines to learn or perceive, or all sorts of other questions that are relevant right now. So this is actually, these are clips from a piece by an old student of ours at Goldsmiths named Terry Broad. He did a set of experiments taking the film Blade Runner, running it through an autoencoder, and re-visualizing the output. So what you're actually seeing is a reconstituted version of Blade Runner. And you can go read about this. He's written very nicely about, why you might want to do this as an artist. And this has now been acquired by the Whitney, which is pretty cool. Another current piece that I'm really excited about by another of our students, Memo Atkin, is called Learning to See, and I've put his description here. Learning to See is an ongoing series of works that use state-of-the-art machine learning algorithms as a means of reflecting on ourselves and how we make sense of the world. The picture we see in our conscious minds is not a direct representation of the outside world or of what our senses deliver, but is of a simulated world reconstructed based on our expectations and prior beliefs. And so he's got a series of art pieces around this idea that you can see online. One of them, I'm going to play for you right here, is using a neural network that is training in real time to come up with a good representation of what is currently happening and what has previously happened in front of his webcam. And so when it's learned a good representation, it can use that to generate an image that's very, very close to what's actually in front of the webcam. But then when he moves, you actually see that it needs to work to come up with an alternative representation that also accommodates that new data. So again, this is technically quite interesting, but I think artistically more interesting. The last point I want to make is that, of course, thinking about replacing people with machines is a little bit artificial and not that interesting. However, machine learning is a set of tools that can support different roles for people, right? It can also support different relationships between artists and their work, and between artists and the tools that they use. And this is quite different. So for instance, Mario Klingemann is an artist whose work I really like, and he has a set of neural network-based tools for generating new visual art. And when he makes this art, it's not that he's just making art as a programmer, right? Making the programs to generate these things are part of the process, but that's not sort of the point. A lot of what he's doing when he's making art is actually running the program, sort of hitting that big red button over and over. And he built himself a Tinder-like interface that allows him to really quickly curate from a really large set of images that his algorithm has produced, and to find the ones that are actually visually interesting or otherwise, capture his attention that he might want to hold on to. And so his role is, it's not like a painter, somewhat as a programmer and a technology developer, but in this part of his process, he's acting as a curator and not as the only creator the way that you would if you had another tool set. A person I've worked with a lot who has another take on the way that machine learning changes her process is a composer and instrument builder named Letitia Tsunami. And she's spoken and written a bit about really not being interested in building new musical instruments that allow her to, be like in control all the time, right? She doesn't want to build a more complicated airplane cockpit where, the idea is that she has this vision in her head and all she needs is an interface to communicate that to the world really efficiently. She's aesthetically, artistically really interested in having more of an interplay with a machine that might actually fight back against her, and finds that creatively very fruitful. So I think, this idea that, again, we may not be artists who bring to the table an idea of what the finished product is, and we just require technology to communicate that, but we are an interplay and communication and even fighting with our technology to say, well, here's my idea, and have it come back at us and say, well, all right, what about this? That can be very fruitful, right? And I think that can be exciting. So anyway, that's the end of my talk. Thank you very much for attending. This has been an interesting experiment for me to try to talk to people who I can't see and can't hear, and I can't, see your questions while I talk. But hopefully I've given you something interesting to think about, maybe an alternative perspective on what machine learning can be good for, maybe a richer perspective on how machine learning can impact and support human creative practice. So by the way, I've got a free online class aimed at musicians and artists where we go over a number of especially supervised learning techniques. I use this with my students at Goldsmiths as well to introduce machine learning to people who are making games or music or art. Cadenza also has some online classes in TensorFlow for students who want to start doing generative art of the sort of thing, type of art that I've shown you so far. So with that, thank you very much. Feel free to tweet at me. Feel free to visit my website. And I'm going to come back to the window here. If you want to ask questions and hang around, type your questions in the chat window, and I'll hang out for a bit. To create a database of audios, do we violate the IP when we train our models using proprietary music? That is a good question. I think there's, as with many things, a legal perspective on that and an ethical perspective. I don't think the legal perspective is well defined, right? People have enough problems fighting over when IP has been violated when machine learning is not involved. I'm trying to remember if it was Xavier Serra or Francois Pache, but there's been a bit of academic writing about that you might look up, especially around like, hey, I want to build a melody generator. I'm going to train it on all these other melodies. How might I avoid plagiarizing someone else's melody? So I don't think it's a solved question either legally or technically, but yeah, super interesting. Next question. If we want to create such a system as Doopdeck, what are the ways to reduce dependence on human experts? Yeah, I think that's a good question for Doopdeck, right? A lot of the most successful systems that are out there that produce music that is compelling or that's compelling, you have humans in the loop, not just curating the stuff that comes out and throwing away the garbage, but deeply embedded in the design process, saying, this stuff looks good or this stuff sounds good, and because we tweaked this parameter, so let's focus on this parameter. Yeah. All right. Unable to talk, send me an email. Yeah, you can find my email online. What is the most radical application in terms of music and to unlock the interactive potential of sensors? The most radical application. That's a good question. Depends on what you mean by radical. I think Letitia Tsunami's work, who I mentioned at the end, her work is conceptually radical in some ways, right? The idea that she's trying to, explicitly build these systems that are sort of in between the system being in charge and her being completely in control. And she also makes really beautiful music. I don't know that, her music itself isn't radical in that, it's going to like destroy your eardrums, but some of it is. Unlock the creative interactive potential of sensors. A lot of the other stuff that in the music domain that's interesting that you might enjoy looking at if you're not coming from this domain is look at the new interfaces for musical expression conference, because there are a lot of really, really crazy, weird instruments that people write short papers about and present there. There's also concerts there where people are just, making stuff with whatever. So take a look at that. Are there ML services with random data? Not that I know of. I could be wrong. Yeah, randomness is definitely important for a lot of creative work. Yeah, and this experiments with Google, they actually, so this is, if you haven't been there, it's very intentionally like a simplified version of Weka Nater that you can just play with in your browser. So it's pretty cool. I'm a regular ML user. Where's a good technical starting point? Libraries, tutorials. Depends on what kind of stuff you're interested in. If you're interested in making generative content, I would suggest Parag Mittal's Cadenza course, probably. I would also suggest looking at the Magenta GitHub site because they're, open sourcing a lot of their stuff for both music and visual art. Parag's course. Any cheaper sources? It's hard to find, either things are free or, $50 is a pretty good price for stuff that's not free. Start with the TensorFlow tutorials. Look at again, Magenta website, Magenta GitHub is all free. A lot of tutorials, if you look at Distill.pub, for instance, it's not explicitly about creative work, but combining that with, with an academic paper that you read about content generation stuff, you should be able to make stuff with that. Literature, take a look at, again, in music, the NIME conference, look at, computational creativity, I think the International Conference on Computational Creativity, see what people are, see what researchers are doing. Cool. All right, I'm going to take off. Thank you, everybody, for attending. Pleasure talking with all of you. Bye, guys.